Welcome to the training course on IBM Scalable Architecture for Financial Reporting, or SAFR. This is Module 21, the SAFR write function. Upon completion of this module, you should be able to describe uses of the SAFR write function, read a logic table and trace with explicit write functions, properly use write function parameters, debug views containing write functions. This module covers the WR function codes in more detail. These function codes were covered in training modules 11, 12, 17, and 18. Standard SAFR views always contain one of these four write functions, either writing a copy of the input record, writing the DT area of an extract record, writing the standard extract record, or a summarized extract record. Typical views contain an explicit WR function in the logic table, almost always as the last function of the view. This can be seen in the logic table on the left. In constructing more complex SAFR applications, at times greater control over what type of records are written, where, how many, and when they are written is required. The write function is a logic table verb which gives greater control over when WR functions are placed in the logic table. The write function inserted into a view as logic text creates additional WR functions like the logic table shown on the right. Let's look at two examples of problem where the write verb can help solve. The write function can be used to flatten records that have embedded arrays, creating normalized records. This is possible because for each record read by GenevaERS, multiple records can be written. In this example, from customer record 1, 3 records can be written for products A, Q, and C. Another typical use of the write verb is to split a file into multiple partitions. Partitioning is important to be able to increase parallelism of the system in later steps. For example, suppose the daily transactions are delivered in a single file, yet the SAFR environment has multiple partitions, a master file for each set of customers, perhaps by state or for a range of customer IDs. To be able to add the day's transactions to customer master file, the daily file must be split into multiple files, one to be used in each master file update process. To do this, the write verb is inserted into logic text if statement, testing the customer ID, and writing records to the appropriate file. The write verb and associated parameters control all aspects of writing records, including specifying which record type to write, which file, DD name to write it to, and if a RightExit should be called. Let's first review how these parameters are controlled on standard views when the write verb is not used. The following rules determine which logic table function is generated when a view contains no write verb and calls no RightExit. Views which use the format phase, either for file format output or hard copy reports, contain an implicit WRXT function to write standard extract records. Views which use extract time summarization, which requires standard extract file format records, contain an implicit WRSU to write summarized extract records. File output views which do not use the format phase are extract-only views. Views which are copy input views, specified by selecting source record structure, contain WRIN functions. All other contain WRDT functions to write the DT data area of the extract record. Almost all use of the write verb is for extract-only views. Views which do not use the format phase. Because the WRXT and WRSU functions write standard extract records, which are typically processed in the format phase, they are rarely used in conjunction with the write verb. The DD name used for extract-only views can be specified 3 ways, as reviewed on this slide and the next. If an output physical file is specified in the view properties, the output DD name associated with the physical file will be used. In this example, the output physical file is output01. If we find the DD name of the physical file output01 by selecting physical files from the navigator pane, opening the output01 physical file shows the output DD name is also output01. If the physical file value is blank, a new DD name will be generated at runtime. The most common generated name is the letter F followed by the last 7 digits of the view number, using leading zeros if required. In this left-hand example, the DD name is F000099. Alternatively, an extract file suffix can be used. If the extract file number is assigned a value, the extract engine concatenates the assigned number to EXTR with 3 digits representing the extract work file number, beginning with zeros if necessary to form the DD name to be used. In the right-hand example, the extract records will be written to the file assigned to the DD name EXTR001. The last parameter the write verb controls is whether a RightExit is called. When the write verb is not used, RightExits are assigned in View Properties in the Extract Phase tab. The RightExit is called as part of the implicit WR function generated for the view. These are the elements of the write verb syntax. The write verb keyword can be followed by 3 parameters which specify 1. Source, 2. Destination, 3. User exit. The source parameter can be used to specify 3 possible sources. Input data, which means the view is a copy input view. The extract file containing a copy of the input record. 2. Data, which means the DT area is to be written to the extract file. 3. View, which means the standard view extract record is to be written to the output file. The destination parameter allows for modification of the target for the write. 1. The extract parameter allows specifying the DD name suffix of the extract file, or 2. The file parameter allows associating the write to a specific logical file. The user exit parameter allows specifying a user exit to be used. The following are examples of write functions. Each of these example statements first tests a field 4 to see if the value is numeric. If it is, then data will be written in some way. In example 1, the input data will be copied to an assigned copy input, source equals input physical file, associated with a specific logical file, the destination equals file. In example 2, the write verb causes a call to the db2 update user exit. User exit equals db2 update. It passes the DT area data of the view. Source equals data. In example 3, the write verb writes a standard extract record, source equals view, to the DD name EXTR003. Destination equals extension equals 03. The write verb can be used in either record level filtering logic or column assignment logic. When a write verb is used in record filtering, the select and skip verbs cannot be used. The write verb replaces the need for these words. The logic shown here is record level filtering logic and could be used to partition a file containing multiple customers into individual files. Record level filtering requires the use of the source equals input parameter. This parameter copies input records to extract files. This is required because no columns are created prior to the execution of record level filtering. The only valid output is to copy the input record. In this example, the logic is the record filter test the customer ID. If it is cust1, then the record is copied to the DD name EXTR001 because of the destination equals 01 parameter. The second if statement will copy customer 4 records to EXTR004. Because the logic is mutually exclusive, the customer ID can only be cust1 or cust4, not both. The total output records will equal the input records, except they will be in 2 different files. Column assignment logic can use the source equals input parameter if desired. More frequently, it uses the source equals data parameter. This parameter writes all DT columns that have been built in the extract record to that point. Thus, logic can be used to select parameter fields from the event file and write a fixed length record to the output extract file. Remember that the logic table creates fields in order by column numbers, from left to right. This affects which columns should contain the write verb. With a write verb in multiple columns, multiple records of different lengths will likely be written to the extract file. This example attempts to break a record with an array into multiple individual records. The write verb in each column causes an extract record to be written with the DT data built to that point in the logic table. As each field is added, the record becomes longer. This is not typical a desired SAFR output. Alternatively, the write verb is often placed only in the last column of view, thus acting upon the extract record after the columns have been built. In order to change the previous column, the logic text can reference those columns specifically. Thus, values in prior columns can be manipulated within the last column prior to the use of the write verb. This example again attempts to break the array into multiple records. Because logic text can refer to previous columns, logic can be placed in the column 4, which changes the value of column 3. Thus, both the product ID and the amount fields are set in column 4, and then the record is written. Then these values are overwritten by the next product ID and amount combination, and another record is written. Finally, the last two fields are moved, and the last record written. This is a more common design of a view containing multiple write verbs. Let's take a moment and contrast the prior view with multiple write statements in one view with using multiple views. Because each view contains its own implicit write function, by writing multiple views, we could break apart the array. To do so, the first view would reference the first array fields, product and amount 1. The second view, the second set of fields, and the third set of views. Thus, by reading one event file record, 3 records would be written. The downside of this approach is that the logic to populate fields 1 and 2, the customer ID and tran date, would be replicated in all 3 views. Changes to these fields would need to be made in 3 places. Using the write function keywords, any of the WR functions can be generated in a logic table. In these example logic tables, a standard extract-only view without a write verb is shown on the left. This view has one WR function as the last function in the logic table. The logic table on the right shows the result of a WR verb with source equals data and has been coded multiple times in the logic text. Note that the sequence number for each is 001, meaning all these write verbs are contained in the logic text of column 1. Each of the logic table functions immediately preceding these WRDT functions may modify the extracted data during the extract phase. Each will result in a different extract record being written to the extract file. This module describes Sapper write functions. Now that you've completed this module, you should be able to describe uses of Sapper write function, read a logic table and trace with explicit write functions, properly use write function parameters, debug views containing write functions. This module describes Sapper write functions. Now that you have completed this module, you should be able to describe the uses for the Sapper write function, read a logic table and trace with explicit write functions, properly use write function parameters, and debug views containing the write function. Additional information about Sapper is available at the web addresses shown here. This concludes Module 21, the Sapper write function.